Hello my dear loving students. Today we are going to see one derivation on the topic stresses in the bars of different section. Understand? Once again I will repeat it. Stresses in the bars of different section. Actually previously we were solving about stresses of same section. Understand? Stresses on same section. That means only one length was given. So according to using that one length we were solving stresses. But today we will see if we will have more than one length, more than one diameter, more than one area, even though more than one bar also, then how we will find the stress of particular section. Understand? So we are going to see that derivation. So first of all we will draw our diagram. Suppose that this is the first section. Understand? This is our first section. We will say as section 1. Then we will take another section. This is our section 2. And then we will take another section. This is our section 3. This section has length L1. Suppose that this section has length L1 and section 2 has length L2 and section 3 has length L3. That means they don't have similar length. They all have different length. Understand? And suppose that section 1 has area 1, section 2 has area 2 and section 3 has area 3. That means all the three sections has different areas. Understand? First of all, once again I will repeat everything. Actually we are going to find the stresses of different sections. That means each and every section will be different from others. Understand? Actually section 1 has different length, different area. Section 2 has different length, different area. And section 3 has also different length and different areas. Understand? But all the entire section is loaded with axial load P. Axial load P. Understand? This is P, load. Already we have seen everything, na? P is our load. So, we are applying one axial load P. Then how we will find the stresses of different section? Understand? How we will find the stresses of different section? Now we will see. First of all, we will know what are these terms stand for, like P, A1, L1, these things. Why or what they stand for? Understand? We will see first. Where P is equal to axial load. Axial load on sections. L1 will be length of section 1. A1 will be cross section area of section 1. Understand? Similarly L2 and A2 will be length and cross sectional area of section 2. and L3A3 will be length and cross sectional area of section 3. Understand? Once again I will repeat everything. Actually, here we are using, or here we are having 3 different sections. Section 1. Section 1 has L1 length and A1 area. Section 2 has L2 length and A2 areas. Section 3 has L3 length and A3 areas. And all the sections having one axial load as P. Understand? So that's why we have mentioned here P is equal to axial load on sections, all the sections. L1 is equal to length of section 1. A1 is equal to cross sectional area of section 1. L2 and A2. L2 and A2 is length and cross sectional area of section 2. L3 and A3. L3 and A3 are length and cross sectional area of section 3. Understand? Then already you know one more term, E. What E stands for? E is equal to Young's modulus of the section. What is E? E is equal to Young's modulus of the section. Understand? You have to keep these things in your mind. Before we are going to derive stresses of different section and the extension of different section, you have to know these things, because during derivation we will use these terms only. Understand? Okay, I am going to erase it. Please note down. You can pause the video and take a screenshot also. Okay. Yes. Now we will see how to find stresses of different section. Stress of section 1. What is the stress formula? We are denoting stress as sigma. So, sigma 1 will be, because we are finding the stress for section 1. That's why we are using 1, sigma 1. Understand? If we were finding the stress for whole section, then directly we would have written directly sigma. But now we are finding the stresses for section 1 only itself. So, we are using sigma 1. So, what is the stress formula? Stress is equal to load by area. Which area? Area 1. Because we have to find the stress only for this section. So, area 1. Similarly, stress of section 2 will be P by A2, and stress of section 3 will be P by A3. Understand? Once again I will repeat everything. What is the stress formula? Stress formula is load by area. So we are finding a stress for section 1 itself. So for stress for section 1 will be P, because load is similar or same for all the section. Understand? Only area is different. So we are using same load everywhere. So sigma 1 is equal to P by A1, sigma 2 is equal to P by A2, and sigma 3 is equal to P by A3. Understand? Now we will find strains of different section. Understand? First we have find the stress of different section. Now we will find a strain of different section. Understand? A strain of different section. So what is the formula for a strain? Already we know that a strain is equal to sigma by E. Why sigma by E? You know, Because already we know the relation. Young's modulus is equal to stress by strain. So if we have to find the value of strain, then what will happen? Young's modulus will come here to here, then strain will come here to there. Understand? You know these things. These things are very simple. So a strain, how we will find a strain? So a strain for particular section, section 1, how we will find? E1. So a strain for section 1 will be E1 is equal to sigma 1 divided by E. Understand? Sigma 1 divided by E, and we know that sigma 1 value also. So E1 is equal to sigma 1 value. What is sigma 1 value? P by A1. So P by A1 into E. This is the value of strain in section 1. Understand? This is the value of strain in section 1. Why? Because already we know, see, this is the formula for a strain. A strain is equal to a stress divided by Young's modulus. So already we have gathered the value of stress for each and every section. Section 1 has P by A1, section 2 has P by A2, and section 3 has P by A3. So what we have done here, we have taken the value of stress 1 from here and substituted in the formula. So how much we got for section 1? For section 1 we got a stress as E1. We are denoting a strain as E1. So a strain as P by A1 into E. That means load divided by area 1 into Young's modulus. Similarly, if you will see for section 2 and section 3, what the value of a strain will be? E2 will be how much? P divided by area 2 into E. And for section 3, a strain will be P divided by A3 into E. Understand? Once again I will repeat it. For a strain for section 1 will be E1 is equal to P divided by A1 into E. For first section. For section 2, a strain will be P divided by A2 into E. And for section 3, a strain E3 will be P divided by A3 into E. Why we are finding differently or separate? Why we are finding separate strain? Because we have to find. Before we were getting only one section. Understand? So we were finding only one strain, one stress, everything. But now we are getting different section, and each and every section will have different stress value, different strain values, and everything will be different. Understand? That's why we are finding. So already we have find different value of stress. Stress 1, stress 2, and stress 3 for all three sections, and strain 1, strain 2, and strain 3 for all three sections. Now it's time to find what we have to find. Already we know one more formula. What formula we know? A strain is equal to change in length by original length. Already we know this formula, na? A strain is equal to change in length by original length. Using this formula, we will find the total extension of the bar. Understand? Using a strain is equal to change in length by original length, already we know the formula. Using those formula or this formula, what we will do, we will find the total extension of the bar. How much extension actually it occurs on the bar. Understand? We will solve these things. Please note down these things. Okay? Actually, till now we have find a stress value and a strain value of different section. Now one more thing we have to find, extension of the bar. So if you will see extension, what is extension? Extension means change in length of the bar. So here we are having three different sections. This is section 1, section 2, and section 3. And each and every section will have some another value of extension. That means change in length. So if we have to find change in length of first section, what we will do? How we are finding change in length? Actually already we know one formula. A strain is equal to change in length divided by original length. These things we know. So how we will find the change in length of this one? So what we will do, strain 1 will equal to change in length of 1 divided by original length of 1. Understand? How we will find extension or change in length of first section? What we will do, we will find, already we know one formula, strain equal to change in length by original length. So what we will do, we will put 1 in each and every terms. Understand? So strain 1 will be equal to change in length by 1, change in length in 1 divided by original length of L1. Understand? Now what we will do? How we will do? We have to find change in length. These things we have to find. We have to find this term, change in length, that is also known as extension of the bar of section 1. So how we will find extension of section 1, that is dL1 will be equal to E1 into L1. Understand? Cross multiplication. L1 will go that side, so it will, here it is in divide form. So if it will go that side, it will multiply with strain. Understand? So change in length of section 1 will be, or extension in section 1 will be a strain of that particular section into length of that particular section. Understand? And one more thing, we know one thing. What is the strain 1? E1 value? E1 value is P divided by A1 into E. So we will substitute here P divided by A1 into E into L1. That means P into L1 divided by A1 into E. This is the value of first extension of the bar. This is the value of extension of the section 1. This is the value of extension of the section 1. That means change in length of section 1. This section 1. Understand? Similarly, we have to find the change in length or extension of different sections, like section 2 and section 3. Now I am going to erase it this side. Please note down. Okay, I will erase this side. Now what we will do, similarly we will find the extension or change in length of second section, that is DL2. Similarly what will come? P into L2 divided by A2 into E. Understand? This is for second section. This is for second section. And similarly for third section, what will happen? What will come? DL3 is equal to P into L3 divided by A3 into E. Already we have got all the three different section change in length value. That means extension of all three sections we have got. Understand? First one is DL1 is equal to P into L1 divided by A1 into E. Second one, DL2, that means change in length 2, or that means extension in the section 2 is equal to P into L2 divided by A2 into E. And third, extension in section 3 we got as DL3 is equal to P into L3 divided by A3 into E. Understand? Now what we have to do, we have to find the extension of the total var, all the section as united. Understand? Now we will consider section 1, section 2 and section 3 as in a united form. So we have to find the total extension of the bar. How we will find? How we will find total extension? Suppose that I am giving 3 students 10 rupees. If I will ask you to add all the amount or all the money which I have given to you, how you will do? You will add all the 10 rupees amount together. Same thing we will do here. what we will do here, we will add all the extension of each and every section together to find the total extension of the bar. Understand? So same thing we are going to do here. So total extension, that we will call as DL. Total extension, that we will call as DL. So what will it will how it will be added? DL1 plus DL2 plus DL3. Understand how it will be added? Total extension, how we will find? DL is equal to DL1 plus DL2 plus DL3. Understand? Now what we will do? We will substitute each and every values here. Please give water. Now what we will do? We will substitute each and every values like DL1 plus DL2 plus DL3 together to get the total extension of the bar. Understand? Excuse me. So now we are going to substitute each and every values here in this equation. So we will get as total extension is equal to DL1 P into L1 divided by A1 into E plus DL2 here, P into L2 divided by A2 into E, and third one as P into L3 divided by A3 into E. What we can take common from these three equations? What we can take common from these all three equations? We can take P divided by E. We can take common. So DL is equal to P by E, L1 by A1 plus L2 by A2 plus L3 by A3. So if our question says us to find the total extension of the bar, then this is our final equation. Total extension of the bar will be counted or will be calculated using this formula, P by E, where P is equal to load, E is equal to Young's modulus into L1 by A1. L1 will be length of section 1 divided by A1. A1 will be cross sectional area of section 1 plus L2 by A2, similar same thing, plus L3 by A3. So we will use this formula to calculate the total extension of the bar. Understand? एक बार फिर से आप सभी को हम लोग हिंदी में आपको हम बताने जा रहे हैं, मतलब करना क्या, एक्चुअली करना क्या था हमको, ये हमारा डिफरेंट सेक्शन, ये सेक्शन 1 है, ये सेक्शन 2 है, ये सेक्शन 3 है, सारा सेक्शन का हमको डिफरेंट क्या निकालना है, स्ट्रेस का वैल्यू निकालना है और हमको टोटल जो बार है उसका टोटल एक्सटेंशन निकाला, मतलब उसका चेंज कितना होगा लेंथ में, उसको निकालना है। हम लोगों ने क्या किया, फार्मूला यूज करके सारा चीजों को किया, समझ में आ गया। और यदि एक चीज और आपको हम बताना चाह रहे हैं, यदि मान लीजिए ये हमारा तो मान लीजिए एक ही बार का बना हुआ है, ये हमारा एक ही मटेरियल का बना हुआ है, सेक्शन 1, सेक्शन 2, सेक्शन 3। सपोज दैट यदि हमारा तीनों सेक्शन डिफरेंट मटेरियल का बना हुआ होगा तो मेरा यंग्स मॉडुलस का वैल्यू डिफरेंट होगा। अंडरस्टैंड? लिसन, एक्चुअली इन दिस डेरिवेशन वी आर हैविंग सेम यंग्स मॉडुलस फॉर ईच एंड every section, but suppose that if we will get the different section of different material, then our Young's modulus value will be different in each cases and each material. So what we will do, only we will take common as load, then we will multiply Young's modulus here also, E1, Young's modulus of section 2 here, E2, and Young's modulus of section 3, E3 here. Understand? So this is our formula to solve numerical. So in next class we will solve numerical based on our this formula. Thank you.